3, 2, 1.
Los gets.
Magma is in the plate, so the plate must have gone this way and then this way. We're tapping into real state-of-the-art science here.
7 centimeters per, well, wouldn't that be important? Per year, maybe. So it's pushing down on the oceanic plate.
Bending the
plate.
I thought something from the moon landed on here.
Yes, there's 3 theories.
Oh.
Yeah, German. You have magma.
There's water in the earth.
Hello. Hi.
Welcome to
Alexus. Oh, we switched. Welcome to
Alexus Explain.
A series where
I ask Alexis questions
and I do my best to answer them.
Today, I have a question about volcanoes.
Diamond Head specifically, because Hawaii is the place with all the volcanoes.
Yeah, Alexis explains to me how volcanoes are formed, where the magma comes from, how plate tectonics work.
All the fun stuff, layers of the earth. But before you watch the rest of this video, be sure to subscribe so you can see when we post new videos.
We have a new series in the making where we ask other experts.
Yeah, it'll be called Someone Explain, and we're really excited about it.
Yeah, subscribe to not miss that.
Yeah.
If you've ever been to Hawaii, you know that there's some pretty cool craters to look at.
Yeah.
One of the ones we love the most is Diamond Head.
It's actually right by where we live.
Yeah, it's really close. Whenever we go to the beach, we see it, and it's just so pretty.
You can see it from where we are now. But yeah, you can see it from Ala Moana, from main Waikiki.
Yeah, it's pretty big. So one day I was wondering, what is Diamond Head?
Crater.
A crater?
Yeah.
How did it come?
How did it form?
How did it form?
Yeah. Good question. Oof. How do I begin?
Is it difficult?
There's a long story to it.
Okay.
So Diamond Head itself is a crater, but it was never its own active volcano. Which I didn't know. It's a part of a volcano, but it's not its own volcano.
Craters are from volcanoes?
Yes. Craters are the sides of volcanoes, kind of.
The sides?
Like the sides.
Oh, the side.
Yeah.
Oh, of old volcanoes?
Yeah.
Mauna Kea, is that a volcano?
Yeah, on Hawaii. Big Island.
Guys, apparently I made the TikTok coffee from 2 years ago. I didn't even know. I was just mixing things together, and here's Alexis telling me, oh yeah, my sisters used to make this one. It was really big on TikTok. It is really good. Okay, how do volcanoes work?
How do volcanoes form?
Yeah.
Okay, so back to plate tectonics. You must have learned about plate tectonics. Okay.
Yeah.
So Hawaii is an island chain, right? So we have a chain of islands. It's Big Island, which is the youngest, Maui Islands, Oahu, and then Kauai, with Kauai being the oldest. Kauai has no active volcanoes.
Okay.
We also have no active volcanoes, right?
Yeah.
But Big Island does. And there's even a newer island that's forming in front of Big Island, the youngest one that's still underwater. It's like 1,000 meters underwater still. But it's called, I think it's Leahi. Cute, right?
What?
But it already has a name, and it's not even above the surface.
Do they erupt underwater?
Yeah, so Hawaii is on a plate called the Pacific Plate, right?
Okay.
It's a oceanic plate, which means it's made up of basalt. Okay. Basalt is the volcanic rock that you think of, the dark black rock. So you have this plate that's moving over this area of the earth. And you know the earth is really hot at the center and then gets cooler as you go out through earth. Like Earth's core is really hot. So there's these things called hotspots in the earth, and then the Pacific Plate passes through and it moves northwest. So you have this plate and this hotspot here. The hotspot's fixed, but the plate is slowly moving over. I think it's moving at 7 centimeters per, well, wouldn't that be important? Per year, maybe, but the rate that fingernails grow. It's sliding over. So as it's here, it's forming volcanoes at this point, which would have been Kauai.
Okay.
Right? And then it forms volcanoes that pushes lava. Lava is once magma reaches the surface. Lava eventually cools, things come eroded, but it forms new land, mountains, and Kauai.
That's how Kauai came into existence.
And then over time, it keeps moving so that volcano is no longer active. Like it's active when it's under the hotspot.
Oh, when it moves, it's inactive.
Yeah, and I think there's always a chance that, like Oahu, for example, has passed over the hotspot and no longer has active volcanoes, but I think there's a chance that one of them can still erupt, but it's very, very slim.
Okay. Why?
And yeah, it says the hotspots are actually much bigger than we think they are. Several kilometers or something.
Oh my gosh.
Yeah.
Where are the active ones in Oahu?
Where are the active volcanoes? On Big Island, which is currently...
Oahu.
Oh, on Oahu. They're not active.
The maybe active.
Okay, going back to how Diamond Head was formed. So Oahu is technically made up of 2 volcanoes. Can you guess? What are the names of the 2 volcanoes that make up Oahu?
Is it maybe the eastern mountain chain and the western mountain chain?
Yeah, so Waianae volcano and the...
Oahu.
Yeah.
Oh, but they're just lines, not round.
No, exactly. So Waianae was the first one, and I think that was 2.6 to 3 million years ago. And then you have the Ko'olau volcano on the east side, where all the pretty ridge hikes are. That was formed 1.8 to 2.2 million years ago, so a little bit after.
A lot after.
Yeah.
But also a long time ago.
Yeah, long time ago, right? So these 2 were formed.
I just don't understand why they're long and not round.
It's just because things become eroded over time.
They used to be round?
Those are the ones that are under the hotspot, so they're just erupting, creating these mountain ridges and stuff. Then there was a period of, I forgot how many millions of years of it just being totally quiet. They were inactive. And then it's called a rejuvenation stage, like a post-eruption thing. It just suddenly erupted again. It's some kind of different eruption that forms this different kind of volcano called a tuff volcano. So
I'm so confused. Are you understanding anything?
yeah, I'm sorry if I'm bad at explaining, but it's this whole story. Kind of cool. Diamond Head, Cocoa Crater, Punch Bowl, and I think one more crater were formed from this eruption, but they're called tuff cone volcanoes because they were formed differently. So when it erupted, you have the magma. Water and the magma interact, so the water quickly turns into steam and the magma turns into ash, and these things explode more sideways compared to upward, more like outwards.
That's why it's so big.
That's why it's so big. Yeah. All of these particles and ash get thrown out, and later over time they turn into rock and this thing called tuff. That's why they're called tuff cone volcanoes.
Because they have water in the reaction?
Yeah,
Water?
it's magma interacting with the water. That's how it formed all of these different craters. And that's why Diamond Head, the rim is pretty narrow and the actual crater is really wide.
Yeah.
Kind of shallow, I guess.
Yeah.
It's not this kind of volcano, it's more like...
Yeah. That is what it looks like.
And you know how if you look at Diamond Head, one of the sides is
higher.
Yeah, that's because when all this happened, the wind was blowing southwest.
No.
Yeah, so there's just more stuff on one
That's why?
Yeah, crazy, right?
Oh my gosh, we're gonna show you a picture.
Yeah.
Guys. That really is what it looks like. It's so noticeable.
Yeah.
Because the wind was blowing that way?
Yeah, the wind was blowing toward the southwest.
Crazy. But that was also when the
Forward.
plate was above the hotspot?
No.
After.
Yeah, it was millions of years later.
Should we look up how that works?
Yeah. So we looked up how rejuvenated volcanism works. So this is when...
There's 3 theories.
Yes, there's 3 theories.
Oh.
Yeah, German. 3 theories. Why Diamond Head could have been created. This didn't happen until 1 million years after the original volcano formed. So, first theory is that Big Island is a really big volcano and really dense and heavy. So it's pushing down on the oceanic plate.
Bending the plate.
You have a bend one place, you're gonna have uplifting somewhere else. So they think, okay, maybe this uplift, that part of the crust was solid at depth.
Under high pressure.
Yeah, so it uplifts. Pressure change. This pressure change causes it to become molten.
It's not solid anymore.
Yeah.
Because the pressure is less. Yeah.
So that can possibly cause eruptions.
But there's a second theory.
The second theory is that
There's magma still stored. Not all of it came out.
there's still probably little pockets of magma just below the surface that could come up to the surface if the land changes a bit.
Like landslides.
Yeah,
or something
landslides
like that can
or
happen.
just plate tectonics.
Yeah.
Yeah.
And then the third theory.
Yeah, the third theory has to do with you have the original hotspot and most of the activity is centered right above the hotspot, but as smoke is released from a chimney, some of the smoke is dragged, this way. So they're thinking thinking that's the same thing, that maybe you have this heating, and the heating also goes a little bit downstream, making the other parts at the older islands also a little warmer.
I thought magma came there, but maybe hot material, they say.
So also kind of cool. But they don't really know which one.
Yeah,
that's the important thing. It's kind of unknown.
We're tapping into real state-of-the-art science here.
Yeah.
You know what I don't understand now? I'm wondering, what does that have to do with the water now?
What do you mean?
Now we're kind of saying Diamond Head is different because it's rejuvenated.
Oh, tuff cones.
Also, how do you spell tuff?
Tuff.
Not what I thought.
Sometimes it's called ash cones. Shields.
There are so many different types of volcanoes. Who would have thought? I thought it's just one.
You have magma.
There's water in the earth.
And then, yeah, areas of water.
Under land. You know how I asked why it's a line and not round, the Ko'olau volcano? And probably also the Waianae?
Yeah, Waianae.
The rest fell into the ocean.
Yeah, the eastern side of the Ko'olau mountain range. It's at the size of Brooklyn. Went into the ocean around Kaneohe Bay, Kailua.
The rest of the crater just fell into the ocean. That's why it kind of looks like this.
Yeah, and it's just because it erodes over time, too.
Yeah.
So you have a lot of wind from... That's what it was. There's more erosion on
the windward
east side.
Yeah.
Mountains. That's why they have those really clean cuts in the ridges and stuff.
Oh, yeah.
Compared to mountains in Waianae, which are more just like, I don't know, rock.
Yeah.
They're not as sharp.
Yeah, that makes sense. And you can still, there's little islands on the east side.
Yeah, I think some are remnants of that.
And
which is called the Honolulu Volcanic Series.
Yeah, so that's crazy. And then the water volcanoes, tuff volcanoes.
Tuff cone volcanoes.
Tuff cone. Not all volcanoes have water underneath.
Yeah, but how the water gets, because the water should be on it. But maybe there's fractures in the earth to where some of the water comes in.
Hole.
Yeah,
maybe from the side vent.
Yeah, from the side vent. That's how shield volcanoes are formed.
The Ko'olau and the Waianae ones are shield volcanoes. They're slow erupting ones.
Yeah, the magma flow just kind of goes out and then slowly cools along the edges, so it never gets really big. Yeah, I think that's why you can sit there and watch it erupt. And then you have the steep volcanoes.
But we don't have those here.
No, we don't have them here. One main channel, no side vents.
And it's...
Yeah, and it's really explosive.
That is so cool. And which type of volcano it is, it depends on where it is.
Yeah, I think it depends on the geologic structure, whether it's on oceanic crust or just land, or continental crust, land crust.
Yeah.
Yeah.
Well, I didn't know that that's the word for it.
Yeah.
And there's also those volcanoes when two plates meet, right? And then, or like this, and then... That's a different type of volcano. Not what we have here. That's kind of what I thought, that the Hawaiian Islands were on two plates.
Ah. No, one. That's how we get that chain of islands.
Okay, I understand. So the big mountain ranges, the two ones, were when the hotspot was under Oahu, made Oahu.
Yeah.
And then the other parts fell in the water. So it's only two ranges now. And then a long time after. How long after?
I think it was like 1 million years after.
With some water trapped in.
Well, the water quickly turns into steam, and the magma is turning into ash. And then they're getting thrown outward.
Yeah, that makes the big craters. I thought something from the moon landed on here.
Because there's also those types of craters.
Yeah.
No, I remember being confused. Like, no, they should be volcanoes, but there's also craters in Arizona that aren't volcanic.
Yeah, but that's a different story.
Yeah.
Okay, that's how it worked. And then now the hotspot is under a big island.
And the new island is forming. Yeah.
And the new island.
Also, that's what I was reading. The new island is still underwater, like 1,000 meters.
When is it coming up?
They don't know because sea level is supposed to rise.
Oh!
So if sea level rises, it's going to take longer for us to even see that one.
Right.
But then as sea level rises, the other ones will be partly underwater too.
That also is going to happen.
Yeah.
And that's going to cause more erosion too.
Yeah.
I thought the Earth is just the way it is and it will never change.
Uh-huh.
It seems like it.
I know. I was thinking about it and I was like, wait, we're all on a plate that's slowly moving? Because you know you're on Earth, but I think you just think, you know, I'm on the ground.
All plates are
Not
moving,
like,
right?
Yeah.
That's why there was one big continent.
The supercontinent, yeah.
Pangea.
Mm-hmm. Yeah, I saw your smile.
Something?
Yeah, that broke up, formed the different continents.
So cool. Oh my god.
I was also looking into these hotspots, how the hotspots are formed.
Yeah.
And they're just like, yeah, they're hotter parts of the Earth. And that is kind of funny to think
Can
about,
we see
too.
a picture?
Of a hotspot?
Yeah.
Yeah, kind of like this. Oh, this is the Hawaiian Islands. Oh, the Emperor Seamount chain is also on the Pacific plate, but that's because at one time turned direction.
Oh, they were formed before the Hawaiian Islands?
Yeah, same plate, but it's because it turned direction.
The Hawaiian Islands are like this. Emperor Seamount chain is like this. So the plate must have gone this way and then this way.
Yeah, kind of crazy, right?
Yeah.
But anyway, you have the mantle, where that plume is coming from, and then you have the lithosphere.
That's the plate?
The plate is made up of the upper mantle and then the crust. That's why plates move, because you have solid stuff, but underneath it, it's squishy.
Squishy is lithosphere?
Squishy is the upper mantle.
I don't understand that.
The core.
Core.
Uh-huh. Well, don't color it in, maybe.
Why? I thought it's solid.
Yeah, it is. Okay, that's why you colored it in.
Yeah.
Then you have the mantle.
I had this in high school too, but it was in English, so I never understood. That's not true.
Let's find you a good diagram. Okay, so that's the core. You have the inner core that is solid, outer core, which is liquid. Yeah, that's really hot. Then you have the lower mantle and the upper mantle.
What is this called again?
Inner core,
outer core.
Outer core. Lower mantle, upper mantle.
Lower mantle first?
Yeah. So that's the part that is mostly solid. The lower mantle is going to be more liquid, whereas the upper mantle is going to be more solid.
Yeah.
And then you have the crust that is completely solid. So maybe you can do some dashed lines or something.
Last one's the crust. Yeah, crust.
That's the Pacific plate?
Plate is made up of the upper mantle and the crust. So this and the crust.
Yeah. Yeah.
So upper mantle is also kind of solid.
Upper mantle, yeah.
Is this the jelly though?
No, it's this part, the lower mantle.
This is jelly.
Yeah.
This is why the plates move.
Yeah.
Which one's the lithosphere?
Lithosphere is the crust in the upper mantle.
Yeah.
Yeah, I think we got it all. Actually, magma originates in the lower part of the Earth's crust and the upper portion of the mantle.
So not the outer core.
Not the outer core.
Just kidding, just kidding.
So upper mantle.
Magma is in the plate?
As the partial melting of mantle rocks.
Why isn't the entire Earth a volcano?
Why isn't the entire Earth a volcano? It forms when there's heating. When it gets really, really hot and parts of the mantle rocks melt.
But
so
why
it becomes
do they
molten rock.
melt?
Hotspots.
So there's different reasons why magma would form.
Yeah. The melting temperature of rocks in the upper part of the Earth's mantle where most magma forms. 1,100 Celsius.
Oh my gosh. That's when magma forms. Yeah, how do hotspots come then?
How do hotspots form?
Mm-hmm.
Yeah, it says over unusually hot parts of the Earth mantle. I don't know.
So sometimes this is just really hot.
Just unusually hot, yeah.
And then the rocks in here melt, make magma.
Yeah,
In the plate.
in the plate.
Oh, when the plate with the rocks goes over a hotspot, then the rocks.
Yeah, that just makes sense.
Okay, crazy.
Yeah.
Oh, not what I thought.
I have a fun fact.
Yeah.
Diamond Head is also called Leahi, right?
Right.
Yeah, do you know what Leahi means?
No.
It means brow of the tuna. And they think it's because Diamond Head kind of resembles the dorsal fin of a tuna. Like that. And it kind of does, right?
Oh.
Yeah. So that's how it got the Hawaiian name. And it's called Diamond Head because in the 1700s, these people were exploring Diamond Head and found, I think it was like calcite crystals or something, and mistook it for diamonds. Yeah, so that's how I got the name Diamond Head. Even though there's no diamonds there.
No, but people thought so.
Yeah.
Good thing there are none. They're exploiting the Hawaiian Islands.
Yeah, enough. You're right. But yeah, that's Diamond Head.
Okay, cool. Quick wrap up, maybe.
Quick wrap up. So we talked about Diamond Head and how it was formed. We talked about the two main volcanoes on Oahu, the Hawaii island chain, how that formed, plate tectonics. We learned about thin layers of the earth.
And where magma comes from.
Yeah, where magma comes from, hotspots, a lot.
Yeah. Okay, cool.
All right.
Thank you so much for explaining. I would have never thought.
We would have thought that they were formed by things crashing.
Into the earth.
Meteorites.
Yeah, check out our meteorite.
Yeah, check out that video.
Are there volcanoes on other planets? Maybe we can leave that up to you guys.
Yeah, let us know in the comments if you've done your research on that.
That'd be cool. Maybe we
Yeah.
can do another video on it if you're interested in it.
Yeah, or about other planets, that would be cool too.
Yeah. Are you an expert about another planet?
Talk to us.
Please let us ask you questions.
Yeah. Thank you so much for watching our video. And we hope you learned something. If you enjoyed it, give this video a like. Leave a comment about what you learned. And we'll see you in the next one.
Thank you so much for subscribing.
Bye. So, today we're going to talk about... I love you.
I love you. From 2 years ago?
Whew. These mountain, like,
you're almost
ridges.
hitting me.
Sorry. Yeah, I guess I don't completely understand
Oh.
that.
So it's not magma.
Magma. And we're actually moving on plates.
Maybe that's why I sometimes get dizzy.
Oof, I am hot.
I'm so sorry you're not feeling well.
It's okay. I think just sweating a lot
Yeah, I could tell.
with all the volcanoes. Ugh. I love you. It's for future you.
Editing me?
Editing you. Oof, sorry, it's hot.